Okay, so let's work on this one. Now, if I was going to rewrite in that test, I'd be like, this is a problem I would have because there's nothing really to Google. You can't use your calculator. So let's see. Okay, so let's look at the first one. You guys are awesome. We're going to tangent line to the graph. Okay, so we know that for A, we're going to have y minus something equals slope, x minus something, and that something's 3. Let's get the y first. So we're going to get k of 3 is f of g of 3, which is f of g of 3 is 6. And f of 6 is 4. So we're like, that's the y number that goes there. Okay, now I gotta get the derivative. So k prime of x is, you're like chain rule, f prime of g of x times g prime of x. So now let's get k prime of 3. It's f prime of g of 3 times g prime of 3, which is f prime. G of 3 was 6, and g prime of 3 is 2, and f prime of 6 from the table is 5. So 5 times 2 is 10. Like bam. Part of the way to a 3 plus. Okay, now let's do the next one. Okay, so you're like bam, this is quotient rule. So let's write out the rule first. So h prime of x, and don't let them trick you with the name. It's the derivative of the numerator. So g prime of x times f of x, then it's minus, then derivative of the denominator times the numerator, whole thing over the denominator squared, which is f of x squared. Well, let's just put in the numbers for h prime of 1. Okay, so look back at the table. G prime of 1 was 8. F of 1 was negative 6. F prime of 1 was 3. G of 1 was 2. Whole thing over. F of 1 was negative 6, and you've got to square it. And you could leave it there. If you simplify it out, it simplifies out to negative 3/2. But remember, you can leave your arithmetic. Okay. Now let's do C. I love C. You're like, how are you going to evaluate this? They didn't tell me anything about the second derivatives. You're like, oh, this is fundamental theorem, except you have to use substitution. So let's have u is 2x. That means du is 2. Du dx is 2, which means du is 2 times dx. And if x is 1, that's the lower bound, u is 2 times 1, which is 2. And if x is the upper bound, which was 3, it would be 2 times 3, which is 6. Okay, now let's rewrite the integral. You ready? Okay, I'm going to write it here first. So it's going from 1 to 3, f double prime of 2x dx. Okay. So we know this is x equals, we know this is x equals. We know we need a 2 in there. So let me change color. I need to have a 2 times this dx, which means I need a 1/2 in the front. I know that if x is 1, u is 6. I know that if x is 3, oh no, sorry, if x is 1, u is 2. Get the eraser. Okay, so if x is 1, u is 2. If x is 3, u is 6. So there's my new bounds. Okay, I know that this is u. And I know that, I think we use the mark. Don't we use the markers for this? Let's use this again. So I know that these two things together is du. Now I think I've got my new integral in terms of just u. So we've got a 1/2 multiplier. We're going from 2 to 6. It's f double prime of u du. You know, that cracks me up. So now you can use second fundamental theorem. So keep your multiplier. The antiderivative for f double prime is f prime. So this is f prime of 6 minus f prime of 2. We can get those numbers from the table. It's 1/2 of 5 minus a negative 2, which is 7/2. All right, now let's try mine. Ready? Last one. Okay, so the thing is, for a limit, the first thing you're going to try and do is just check to see. Do it over here. So we're going to check. So if you did f of, put in a 1, 2 minus 2, and you did g of 1 minus 2, you looked in the table, you get 0 over 0. So you're like, oh, I can't evaluate it, but I can use L'Hopital's. So this is limit as x approaches 1 of f prime of 2x times 2 over g prime of x. Now let's see if that works. So we've got f prime of 2 times 2 over g prime of 1. F prime of 2 is negative 2 times 2, and g prime of 1 is 8. So I think this answer is negative 1/2. Hooray!